multiplying polynomials graphically. Now, this is the same visual that I gave during addition and subtraction up here, but the one thing that's different is that when we add and subtract polynomials, we took our highest polynomial, and that was what our answer we achieved. Sorry, the type of polynomial. When we multiply, that is not the case, okay? So if I took a linear and I multiplied it to another linear, think about it, its linear is to the first degree. And so if I take a first degree times the first degree, what I get is I get a second degree, which is quadratic. What we do is we add the exponents, or you can just add the degrees together, okay, which is the same thing. So linear times a quadratic, a linear is a first degree, right? So it's a first degree. And then a quadratic is a second degree. So if we add 1 plus 2, that's a third degree polynomial, which is a cubic. We have linear times a cubic, that is a first degree polynomial, and then a third degree polynomial, which will give us a fourth degree polynomial, which is called a quartic. And then our last one here that I've been going over is a quadratic and a cubic. So if we multiply a quadratic and a quadratic is a second degree, and a cubic is a third degree. So second and the third give you a fifth degree if we add them together. So you get what we call a quintic, which is a fifth degree polynomial. Now, we're not going to really focus too much on these two. We're really focusing on up here, getting a quadratic and a cubic. Now, the one thing you will not get when you're multiplying is if you multiply polynomials graphically, you will not get a linear. Okay, you won't for us. So what we're going to be doing is we're going to be getting quadratics or cubics. You can get a linear, but we don't focus too much of our attention on that. We do focus more on these two types of functions right now, okay? So here we go. We have a linear and linear. I've used the exact same graphs in the previous lectures here that I did recorded. So the one thing is that we have, I'll make this become f of x, and I'll make this blue line become g of x. So we have f of x times our g of x. So it's the exact same process as we did when we add and subtract. We look at the y values and we add and subtracted them. Now we just take the y values and we multiply them. Remember, we want nice values. So the only thing is we can't always just pick any values because they may not fit on our graph. That's the only downfall to this. Usually our add and subtract, you have plenty of points that we give you to be able to fit on the graph. This one is a little different. So I'm going to start more in the middle and then just kind of see where that takes us. So first thing, this right here gives us 0. This gives us 1. So remember it's F, so it's red. So it's red times our blue. And 0 times 1 is equivalent to 1. No, sorry, it's equivalent to 0, my fault. So our first point is right here at, oops, I didn't want to erase all that. Our first point here is at 0. Okay. Sorry, I guess I could have zoomed in on that. So then next we're going to go here. Let's say here our red is at 2 and our blue here is at 0. So we're going to say 2 times 0 is 0. So we go right here. Next, we're going to go to point, and we'll go right here and right here. So here we have 1, and here we have 4. So we have 4 times 1, which just gives us 4. If we were to keep going to the right, we may run some issues, but I'll keep going. We can go one more. I'll show you. Here's 2. And then right here is 6. And so when we take 2 times 6, that gives us 12. So we're going to go up here. And so 12 is essentially right here at 12. So you can see our parabola. You can see I can start tracing my parabola here somewhere like right in here. Sorry, my hand got a little glitch here. But if we kept going to the right, everything would fall off the graph. So let's now go back to the left side. Let's make sure that what we're doing is correct. So right here, both of these points are -2. So -2 times -2 gives you a +4. So we'll go up to 4, which is right here, at +4. And then we're going to go to the left one more time. And right here, we have -3. And this is -4. So -4 times -3 gives me a +12. So we'll go way up here to +12. Now you can see that if we were to connect these points, our parabola, again, goes right in here somewhere. Now I know that you may not be able to know exactly what this point is right here, but you do know that this point is 1, right? So anything times 1 is just whatever you multiplied by. So we're going to say right here is now our next purple point. So this is what we would call our vertex for our parabola. So when we draw this, I'm going to attempt to draw this. So bear with me. So this parabola would be our f of x times g of x graph. Remember, a linear times a linear gives us a quadratic. A straight line times a straight line gives us a parabola.